Hello. Yesterday we talked about comparing data sets, but we focused on box plots and dot plots. Today we're going to continue talking about comparing data sets, but we're specifically going to look at histograms. The learning target, once again, is I can use measures of center and spread to compare data sets. As a reminder, the vocabulary that we want to think about as we're comparing sets of data is the measure of center, which would be like the mean and median, and depending on which one you're using would be which visual you're using, you would use different things. And then also the measures of spread or variability, such as range, inner quartile range, and then future concepts of standard deviation and variance. So for today's lesson, we're just going to look at one example and ask two different questions about it. So you can see on the right-hand side, I have a histogram for show 1 and a histogram for show 2. The question on the left says, a marketing team compares the ages of a random sample of 30 viewers of two popular news shows to decide which product to advertise during each show. During which show should the marketing team advertise a product that is targeted to adults aged 20 to 29? Okay. Now, before we go any further, we want to make sure that we focus on this common error. And that is when you're comparing histograms, you do have to make sure that the intervals are the same. So for example, show 1 has an interval of 10 to 14, so does show 2. 15 to 19, same. Okay, so these have to match up, and if they don't, it is not a good thing to compare. Now we do see that show 2 goes a little bit further, but that's just because show 1's data ended. Okay, so for this question, we're specifically focusing on 20 to 29. So this section right here. And if we look at show 1, there's 0 people in the range of 20 to 24, but from 25 to 29, there are 8. So between the two, there's a total of 8 viewers in the age range we're talking about. Now, if I go down to show 2, from 20 to 24, it looks like there's 3 viewers, and from 25 to 29, there's actually 5. Which actually leads us to see that there's 8 viewers in that age range as well. So at first glance, if we're just talking about the exact number within that range, it doesn't really matter. So we're going to think about it a step further. The median of both actually would fall in the same category. If we counted out number of pieces of data on each side, the median for show 1 falls somewhere between 30 and 34. Same would be true for show 2. That's just kind of a side note. We can figure out the median. Having said that, the only reason that I would maybe say show 2 might be a better option, if I had to pick, is because we can see that there are some viewers on both sides of the data. It's maybe more balanced in the way of it's spread out. So it might just be a better option to use show 2, but I think you could actually argue either way. Okay. So that example is a little more unclear because of the exact same number. But I want you to take a minute and look at the next example, which is looking at the exact same 2 shows. So these histograms are the same as the slide we just looked at. And now it says, based on the sample of 30 viewers, if the marketing team wants to advertise a product that is targeted at adults 25 to 34, during which show should they advertise, and explain why. So pause the video, take a look, and see what you think. Hopefully when you were looking at this example, if we were looking at show 1 for 25 to 34, we already said 25 to 39 has 8 viewers. 30 to 34, however, has 10. So if we're looking at that band of viewership, there are 18 people watching show 1 between the ages of 25 and 34. In show 2, if I look at that same range, 25 to 29-year-olds, there were 5. 30 to 34, we can now see there's 4. So there's only 9 people in that age range. So this example is a little more clear to me because there are significantly more people watching in the age range we're worrying about in show 1. So I would choose show 1 for this example. As you can see, histograms can be a little bit more complicated to look at, but if you have a more specific question like this one, it makes it much easier. The other thing with histograms, again, just as a reminder, make sure that you don't compare them unless these are counting by the same frequencies or by the same intervals. Okay, so that was the only other thing we had to add from 11.2. So we do want to summarize though. Yesterday we spent time talking about dot plots. And if we're comparing dot plots, we want to say dot plots show a particular data point fit in the rest of the data. The nice thing about dot plots, again, is you can see the clusters of data. And this one's more spread out. You can see outliers if they exist. That may or may not be an outlier. You could find the median. We didn't really do that yesterday, but you could by kind of crossing these off and counting your way towards the middle. And we talked about being able to find the mean of that data as well. Okay. Then we went into box plots. The box plots nicely show the minimum, the maximum, and the measure of center, but really we focus on the median. So if we're talking about a box plot, we're going to focus on the median and the interquartile range. Remember, that's where 50% of the data falls, between quartile 1 and quartile 3. And today we talked about histograms, and they allow us to compare data ranges. So again, it's not quite as specific. It's kind of, it's a little more of a range than anything, but which is also in business and marketing, like we just saw, a very valuable thing. Here are just some last minute notes. Measures of center are the mean and median. If it's a dot plot, you can see it can be calculated. You can technically find the median. We also found the mean. If it's a box plot, you can see only the median can be found. Measures of spread are maximum, minimum, interquartile range, and range in general. And in the future, we'll be talking about standard deviation. The box plot, you can see the interquartile range, the max and the min. A dot plot just shows the maximum and minimum. And then this last box down here shows a picture of a histogram, and really only a range of values can be seen in a histogram. It's not exact. Last but not least, if you're someone who likes the summary note sheet, I put the example that we talked about today on this sheet, so you can pause the video and get this down. This would be the notes I would take. What I did is I drew the graphs for the problem that we talked about, and then you can see that I put both questions in here with a quick summary answer. You should now work on your 11-2B Pearson homework. Don't forget to do your teacher's ABA, whether that's a Schoology or Google quiz check-in. And last but not least, I would recommend actually going back today and finishing up any homework that you have from Pearson 11-1 or 11-2. You have 4 assignments, 11-1A, 11-1B, 11-2A, and 11-2B, because those are due tomorrow, Friday, by 5 p.m. Tomorrow you'll be assigned a lesson quiz on sections 11-1 and 11-2. So it would be nice for you to have those done so you can just focus on the lesson quiz. Thanks and have a great weekend.